Hello everyone and welcome to Algebra 2. Today we're doing section 5.4, which is solving radical equations and inequalities. I have to tell you that if you were in school, I would not even have turned on the board. I would just let you start working right away. You can read these directions and start doing problems. Of course, you would in class be working with a group and I'd be walking around, so I am going to do them for you. But before we start, here are all the answers, should you be inspired to try a bunch of them on your own. So you can take a screenshot of that. But here I'm going to do number 1 for you. So your first step is to isolate the radical, which I can do by dividing both sides by 2. Now I have the square root of x plus 1 is equal to 2. Second step, raise each side of the equation to the same exponent to eliminate the radical. So you can't see it, but this is square root. There's a little 2 there. So I'm going to raise it to the power of 2. Square roots and squares are inverse functions, so they cancel each other out. And of course, the last step is to solve my resulting equation. I subtract 1 from both sides, and I get 3. Of course, you can plug these back in to check, but I won't take the time to do that on the video. Number 2, you must isolate the radical first. Now I have the cube root of x minus 3 is equal to 2. Since it's a cube root, I need to undo it by cubing. And now I have x minus 3 is equal to 8. And so x is equal to 11. Number 2, first I'm going to add 1 to both sides, which gives me the cube root of 2x minus 9 is equal to 3. Then I'm going to cube both sides. That's how you undo a cube root, which gives me 2x minus 9 is equal to 27. I add 9 to both sides, which gives me 36. And I divide by 2, which leaves me with 18. On the next one, I add 9 to both sides, which gives me 3. I cube both sides, and I get x is equal to 27. On the next one, this is a square root, so I'm going to square both sides. I get x plus 25 is equal to 4. X is equal to negative 21. So while you can't have a negative under the radical, you can have x be a negative number, because negative 21 plus 25 would give you a positive number under the radical. Next one. Okay, so this is where it starts to get a little harder. So the radical's already been isolated. You can't subtract 1 from both sides. So you're already on the step where you're going to square both sides. Now, if your instinct is to write x squared plus 1, you need to write a big frowny face on your paper to remind you that this is not, or angry face possibly, that this is not true. Okay? When you square x plus 1, you have to do x plus 1 times x plus 1, which is x squared plus 2x plus 1. Okay? So be careful. This is the biggest mistake in this section. All right, so proceeding correctly, x squared plus 2x plus 1 is equal to 7x plus 15. I see an x squared in my equation. What do? Whenever you have an x squared, this is what we spent the last couple chapters on, set it equal to 0 and factor. So minus 5x minus 14 is equal to 0. That would be x minus 7 times x plus 2 is equal to 0. X is equal to 7 or negative 2. If you actually check those, the negative 2, when you put it in on both sides, while the negative 2 doesn't give you a negative under the radical, that's not the problem. It just doesn't make a true solution. Negative 1 is not equal to the square root of 1. So this is considered extraneous. I mean, you should be checking your answers anyway, but this is a great thing to do. All right, there's another one exactly like that if you would like to try on your own, if you haven't been trying anything on your own. But we're going to go ahead and square both sides. And again, biggest mistake, it is not x squared plus 16 or x squared minus 16. It's x squared minus 8x plus 16. I see an x squared in my equation. What do? I set it equal to 0, and I factor. I get two answers. And if you checked both of them by plugging in, you would see that the one did not work. Okay, so last time I said it got harder. Now it gets really hard. You can't isolate the radical any more than it already is. There's just two of them. So we are going to square both sides, but it's not going to make it look as pretty as you want it to. This is not x plus 2 plus 1. You cannot square individual terms any more than you could here. This is still the number one error. Instead, you have to multiply it all the way out, which for some people means actually writing it out. So square root of x plus 2 plus 1. And then you can take away the square symbol. So these two do make, the first times the first does make x plus 1. But the inners make the square root of x plus 2. Sorry, x plus 2. The outers make the square root of x plus 2. The last times the last makes 1. And then on this side, you just get 3 minus x. So this is 2 square roots of x plus 2 plus x plus 3 is equal to 3 minus x. And unfortunately, you're just going to have to start over at step 1, which is isolate the radical. So first, I'm going to move the x and the 3. So the 3's actually end up canceling if I subtract 3 from both sides. But be careful, x and negative x don't cancel when they're on opposite sides. When you bring it over, you'll get negative 2x. And good for you if for a fleeting second you thought, oh, it can't be negative. The square root will never come out to be negative. So now we know x must be a negative, because a negative number times a negative will make a positive. So the square root of x plus 2 is equal to, divide both sides by 2, negative x, square both sides. And now I have x plus 2 is equal to x squared. So remember, what do I do when I have an x squared in my equation? I set it equal to 0, and I factor. X minus 2 times x plus 1 is equal to 0. X is equal to 2 or negative 1. And if you put them back in, you will see that the 2 does not work. So only the negative 1 is the answer. Number 11 is exactly the same kind of problem, giving you a chance to practice it on your own. But in case you get it wrong, I'll do it out for you. X plus 6. The inners and the outers make minus 4 square roots of x plus 6. Negative 2 squared is 4. And on the other side, I get x minus 2. I am going to isolate the radical by bringing everything over to the other side. This time, the x's do cancel because they're both positive. And then this is 10. When I subtract 10 from both sides, I get negative 12. So the square root of x plus 6 is equal to 3. Now I'm going to square both sides. And that gives me x plus 6 is equal to 9, not 3, 9. And so x is equal to 3. And you can plug that back in. If you're taking a test or a quiz and you get one of these wrong, shame on you. You can always check them just by plugging back in. Number 9. You can square both sides right off the bat. I get 10x plus 9 Biggest mistake of the day, this is not x squared plus 9. This is x squared plus 6x plus 9. I see an x squared in my equation. What do? I set it equal to 0 and factor. I know you're a little sick of me saying that, but I'm hoping that it'll help. Now, when you subtract 9 from both sides, that cancels. And sometimes people forget how to factor when there's not a third term. But don't forget about factoring out. That should always actually be your first step. So x times x minus 4, x is equal to 0 or 4. And actually, both of those answers work if you check them. Number 12, a little bit of a different one. So we have 2x to the 3/4 is equal to 8. So the way we can undo that is we can raise it to the 4/3. Raise it to the 4/3. Because when you multiply exponents, you'll get 12 over 12, which is 1. So that's how you would undo it if it was a fractional exponent. But interestingly, as nice and easy as that was, fractional exponents can be hard with numbers. So I'm going to convert that to the cube root of 8, then to the 4th. I can figure that out easier in radical notation. Cube root of 8 is 2, and 2 to the 4th is 16. So this whole side just becomes 16. So dividing both sides by 2, the answer is 8. And just a quick note, there's a lot of steps that I'm showing, but I started to show less. I'm not showing the actual divide both sides by 2. And that's okay. You don't have to show that on your paper either. You're advanced now enough in algebra that, that you don't need to do that. Number 10. A little break. Look at that. We square both sides, and we just get 2x plus 5 is equal to x plus 7. There's no x squared, so I don't have to get x squared all by itself. I don't have to set it equal to 0 and factor. Instead, I can just get x all by itself on one side, and I get x is equal to 2. So this is raised to the 1/2. So last time we did this. That's good. Or you can actually change a 1/2 to square root notation and then square both sides. Whatever's easiest for you. Either way, you're going to get x plus 30 is equal to x squared. I see an x squared in my equation. What do? I set it equal to 0 and factor. X squared minus x minus 30. 0 is equal to x minus 6 times x plus 5. X is equal to 6 or negative 5. And if you plugged those back in, you would see the negative 5 didn't work. So the only answer is 6. The negative 5 is what we call extraneous. So just a little note about extraneous solutions and why they happen. So let's say I told you that x is equal to 1. And then I decide I'm going to square both sides. Now I have x squared is equal to 1. I set it equal to 0. I factor. And I get x is equal to negative 1 or positive 1. But I already knew that x was 1. So why 2 answers? Because when you square both sides, now x could be itself or the negative version of itself and it's still going to produce the same answer. So that's how extraneous solutions are created. Okay, this is our first new one. And you're going to solve it like a normal equation. So I'm going to divide both sides by 3. I'm going to square both sides. And I'm going to solve. X is less than or equal to 16. However, even though that's true, there's actually a lower limit. You need a lower limit. Because you can't have a negative under the radical. there can be no negative under the radical, meaning the square root of x minus 1 can't have a negative underneath it. So how do you figure out what would do that? Well, you're welcome to just think about it in your head. What number would cause this to be negative? Anything less than 1. But instead of just thinking about it, literally just take whatever is in here and make it into this equation. X minus 1 has to be greater than or equal to 0, and then just solve it. That's the safest way to do it. So x has to be greater than or equal to 1, and that's how you get your answer. You only need to do this for less than, only need for less than. Because if it's less than 16, it could become negative. This one's greater than, and you'll see in a minute that we don't need it for this one. So again, I start off the same way as before. I add 3 to both sides. I divide both sides by 2. I square both sides, and I get x is greater than 9. But I don't need another limit, because if x is greater than 9, it could be 10, 11, 12, 100, 1,000, but those are all going to be positive. Being greater than 9 has no concern about being negative. So that is the final answer. And number 16. So I divide both sides by 4, and I get 2. I cube both sides. 2 cubed is 8. And I subtract 1, and I get 7. Okay, I see a less than sign. So do I have to have a lower limit? Again, no lower limit needed. Why though? It's got a less than. Why don't you want to put greater than negative, or greater than, negative 1 again? Because this is a cube root. And cube roots can have a negative underneath the radical. So it is not necessary. Cube roots don't have any restrictions. Square roots don't have restrictions if you're already greater than a positive number. But negative ones, or rather less thans, do, because you can't have a negative underneath a square root. So just make sure you watch out for that. And these last 3, really, if you haven't turned off your video yet and tried them on your own, you really should do that, because there's nothing new on these last 3. So this is already to the 1/3, so I'm going to raise it to the 3. Or if it's too confusing, you can think of it as cube root of 3x, and then you can cube both sides. Whatever helps you understand it. So this just becomes 3x. This is negative 27. X is equal to negative 9. This is a square root, so I'm going to square both sides. I get x plus 6 is equal to x squared. I see an x squared in my equation, so what do? I set it equal to 0, and I factor. It gives me 2 answers, but if you check them both, you'll see that one of them is extraneous, and so you should cross that one off. If you forget to cross it off, you'll lose points. And finally, I'm going to raise this to the 4/3. I used brackets only because there were already parentheses. More parentheses are fine. And this side gives me x plus 2. This is a little tricky. So like last time, I'm going to do cube root of 8 and then to the 4th. And that'll give me 2 to the 4th is 16. So x is equal to 14. There you go. You did them all. Great job. Let's do some word problems. In a hurricane, the mean sustained wind velocity in meters per second can be modeled by V of P, where P is the air pressure. At the center of the hurricane, estimate the pressure, so we're going to try and find P, at the center of the hurricane when the mean sustained wind velocity is 54. So 54.5 is equal to 6.3 square roots of 1013 minus p. So a lot of times the biggest part of the, it's just reading it, knowing what your plan of attack is, but the actual problem is no different than what we've been doing. So I do divide both sides by 6.3, and I get a very long number. I get 8.650793651. I do not want to round at this point. It's really important to me that you don't round. Don't round mid-problem. Instead, just keep using your calculator. So you want to square both sides. If you literally hit the square button on your calculator, it should say answer squared. You don't have to type the word answer in. Just hit the square button and it'll do it. So hit answer squared. And this is now equal to 1013 minus p. So now on your calculator, you can subtract 1013. Again, I haven't let go of that answer. So when you type in, as soon as you hit minus, the little answer should have appeared. Answer minus 1013, right? And is equal to negative p. So of course we want positive p. So you can divide your answer by -1. Make sure you use the negative key and not the subtract key. And you should get 938.164. Now I can round. Make sure you put your units in. It's millibars. If you round at an earlier stage, the chances of your answer being correct to the nearest thousandth are really slim. And that is what I will be looking for. And someday when you're in AP Calculus, that's what they'll be looking for too. You'll be doing a really hard problem, and if the last step you don't have it correct to the nearest thousandth, no credit. Number 2, in an amusement park ride, a rider suspended by cables swings back and forth from a tower. So cool. The maximum speed of the rider can be approximated by this equation, where h is the height at the top of each swing and g is the acceleration due to gravity. Determine the height at the top of the swing of a rider whose maximum speed is 15 meters per second. So they've given you v, maximum speed in meters per second. So that's what they gave you. So 15 is equal to the square root of 2. And gravity, since we're on Earth, is 9.8 meters per second and h. So the word problems in this section are very straightforward. You're just pretty much plugging things in. 225 is equal to, I can multiply that out, 19.6. H, divide both sides by 19.6, and I get 11.4795, and I'm only putting that all out so we can talk about rounding. We want to round to the nearest thousandth, but I need to round that up. So that's going to go to 0, and this is going to go to 8. When that happens, you're not required to write the 0, but sometimes people do it to show that they're not rounded to the nearest tenth, they have rounded to the nearest thousandth, but it's definitely not required. And this height is in meters. As usual, I'm just going to remind you that if you haven't stopped this this video to do the word problems on your own, you really should. Hang time is the time you're suspended in the air during a jump. Your hang time is given by the function t, where h is the height of the jump. Suppose a snowboarder jumps and has a hang time of 1.21. How high was his jump? So they're giving you the 1.21, they're giving you the time, 0.5 square roots of h. So I'm going to take 1.21 and divide it by the 0.5. which gives me 2.42 is equal to the square root of h. Then again, you can just hit square on your calculator and it should square your answer, which is 5.856. And we are in feet. Now, that's just the first part of the question. The second part says, if you double your hang time, does the height double? So let's do that. So we're going to double the hang time. 2.42 is equal to 0.5 square roots of h. So this becomes 4.84 is equal to the square root of h. I square both sides. 4.84 squared is 23.426. So definitely no. You doubled your hang time. You had to go a lot higher to do that. So the answer is no. Number 4. The Beaufort scale, I do not know if I pronounced that right. The Beaufort wind scale was devised to measure wind speed. The Beaufort numbers, b, which range from 0 to 1, can be modeled by the given equation. What is the wind speed for b is equal to 0, or for b is equal to 3? And then write an inequality that describes the range of wind speeds represented by the Beaufort model. So if it's a 0, then they just say that it's calm, but we want to know the actual wind speed. So we're going to take this formula up here, and we're going to do 0 is equal to 1.69 square roots of s plus 4.25 minus 3.55. I add the 3.55 to the other side. I'm going to divide by 1.69, which is 2.100591716. And I wrote that all out to remind you that you should not round at this point. Instead, you have that number on your calculator, so now you should square both sides. So I say square, my answer button does it for me. So now I get 4.41248. You do not have to write all this out on your paper. I'm only doing it to remind you that you can't round at this point. On your paper, you're more than welcome to just show me the rounded number. And then I subtract 4.25, and I get S is equal to 0.162. And then I look for my unit, the wind speed, miles per hour, which makes sense. You wanted it to be something small because it was a very calm wind. How calm? Less than 0.2 of a mile per hour. And then they asked for B of 3. So since this is identical, I'm actually going to let you do one on your own. So I'm going to look for this answer. You can do it the exact same way I just did it, but you're going to start with a 3 over there instead. So make sure you show me that answer when you do your notes. Finally, write an inequality that describes the range of wind speeds represented by the Beaufort model. So we know that when Beaufort is 0, it's only 1.62. Range means everything from the lowest to the highest. So in other words, we need to do it again for 12. So I will do that here. This will be good for the people that need to see the 3. You'll get to see it one more time. 1.69. I'll go a little faster this time. 3.55. So I'm going to add my 3.55 to the other side. I get 15.55. I'm going to divide both sides by 1.69. And I'm going to write do not really round. Even though on your paper, I'm going to show 9.201, I didn't actually round it. I left the number on my calculator. I square both sides. I subtract the 4.25. And I get S is equal to 80. Let me check that answer. Yep, 80.412. So what is the range? The range is 0.162 to 80.412. And how do we express that? Wind speed, S, is greater than or equal to 1.62, which is less than or equal to 80.412 miles per hour. Okay, we just have one left. Number 5. You are trying to determine the height of a truncated pyramid. So truncate means to cut off. So maybe you have the word hyper. If you truncate it and take off the ER, then you have hype. That's what it means to truncate. A truncated pyramid, which cannot be measured directly. The height H and the slant height, so slant height means the diagonal, of the truncated pyramid are related by the formula below. In the given formula, B1 and B2 are the lengths of the sides of the upper and lower bases of the pyramid respectively. So given our triangle, which is when L is 5, B1 is 2, B2 is 4, what is the height of the pyramid? So I'm just going to fill everything in. 5 is equal to the square root of H squared plus 1/4 B2 minus B1 squared. So just to make my life easier, I'm going to go ahead and square both sides. And at the same time, I'm going to simplify that other side. So this becomes 25. This becomes H squared. And 2 squared is 4 times 1/4 is 1. So H squared is equal to 24. So H is equal to the square root of 24. Or we can do it as a decimal, 4.899. And what are our units? Do we have any units? We do not. So we can stop there. All right. That's it for today. I hope you have a great day.